So somebody up front here is realizing, do you guys realize how soon the semester is going to end? I mean, our next test, this Wednesday I'm giving out the practice test for the next test, which is next Wednesday. Right? And then the week after that is review for the final. The week after that is the final. Oh, I'm sorry, yeah, the week after that is the start of finals. We're unlucky or lucky enough, depending on your perspective, to have finals on the last freaking day, June 3rd. Monday, June 3rd. I hate that because it pushes back my summer. And you guys, the students, I would think you would hate that because it gives you that much time to forget everything.
Gives us a day to study, though. It's all good.
On Friday, our
Is that good?
At 3 p.m. on Friday.
So guys, if you were here last time, we talked about how to solve systems of equations by hand, 2 by 2, 3 by 3. So when I say 3 by 3, what I really mean, because today I'm going to almost contradict myself there, but I want you to understand, 3 by 3 means 3 equations, 3 unknowns. There's actually 4 kind of elements, right? The x part, the y part, the z part, and the equals part. When I say 3 by 3, I mean 3 equations, 3 unknowns. So today we're going to talk about how to do this using matrices. And I think most of you at least appreciate what synthetic division does for us. If you don't exactly love it, you at least see what it does for you. So matrices tries to do the same thing for us with systems of equations. What does synthetic division really do for us? I mean, what's the only other option? Long division of these expressions. And that's disgusting. It's got way too much stuff that you don't really need. You add one more term and it adds quite a level onto it. Synthetic division is very simple. It focuses just on the numbers. That's all you care about. So that's the first thing that using a matrix does. So here's one idea of a matrix. And this is not I know Kung Fu kind of matrix, but this is, let's see. Just going to make this work. So, if you were here last time, you saw what this takes. If you weren't here last time, you better remember. So we have these 3 equations, and the process, can somebody try to tell me if you had to do this by hand without using matrices? What's the basic first couple steps?
Probably add 1 and 2.
Yeah, you take a couple of them and you kill a variable. So between these 2, I could double this one and kill the x by adding them together. And you effectively make a 4th equation. Is that 4th equation better than these 3? No. Yes.
Yeah.
It's just as true as these 3 are, but the 4th one's better. Why? It's got less unknown stuff in it. Right? It's almost too easy of a definition of what that means to be a better equation. You got less stuff you don't know in it. That's better. The best equation is where you have only one thing you don't know, one variable, because then you know it. X is 7 days. So I take 2 of them and I kill a letter, and then I take another 2 and kill that same letter, and then I have 2 equations with 2 unknowns, which is easy. Alright, so that's nice. I mean, that's doable. It's just kind of gross. It takes a long time, whatever. So what does this look like as a matrix? And actually, to be more specific, this is an augmented. Oh yeah.
What does that word mean?
It means added onto.
We write it in rows and columns.
Exactly. So in the same way that synthetic division has a very specific order you have to follow, that's what allows me to throw out the variables, because I understand that the x cubed term is here, the x squared term is there, for example. If I'm missing one, I got to put a 0 there. Because of that very strict way to set it up, that's what allows me to just ignore the variables and only look at the numbers. Same thing with matrices. I better have x, y, z number columns. So as I go through here, all I'm going to do is just like synthetic, I'm just going to take the coefficients. So what's that first row going to look like?
1, 1, 1,
1.
Yeah. 1, 1, 1, 4. And then negative 2, 3, negative 1, negative 1. 3, negative 1, 2, 6. Looks better already. I personally kind of put in here, that kind of shows me where my equal sign is. I don't think the book does that, but I always just do it. So if I do that, I just do it automatically, don't even think about it, just to let you know. If any of you have to go all the way to a class called linear algebra, anybody know that they have to do that? Oh yeah, like future engineers, or actually there's anybody ever heard of Pandora? The online music thing?
Yeah.
That uses the ideas of linear algebra to tell what other groups or songs you might like based on what you already have told you that you like. So it's created by researchers who happen to love music. So that's why they make it so easy to get into it. You don't have to pay for it, you have to do a few ads and stuff. But they want data. They want more and more data to improve their algorithms, their equations to predict what you like. So whenever I teach linear algebra, I always bring that up and kind of show people how that might fit in, because it would be a matrix basically with up to like 300 to 450 entries. That's what linear algebra just takes this and goes crazy with it. Let's stay a little less crazy here. So somebody tell me, do exactly what you just told me. What did you just tell me to do? What's the first step here? If I was looking at it here. Yeah, multiply this first one by 2. Because then I can add it to this one and it would cancel it out, right? So just to see what it would look like here. So I do twice 1 plus 2. So this would be 2x plus 2y plus 2z plus 8. And 2 would be negative 2x. And then you add them together, what do you get? Poop. 5y plus z equals 7. And that would be your equation 4, which is a better equation.
In equation 1 and 2, the z was already getting cancelled, so...
Oh yeah, you could have killed the z's. Sure.
Either.
Yeah. But I'll tell you this, when you first start doing matrices, you really should start the process I'm going to show you. To keep it straight, you should start this column, and then move to this column, and then move to that column. And what we're going to do then is we're going to kill both of these. They're going to move here and kill a couple y's, and then we're going to move here and kill a couple z's. And if we can do all that, we'll have 1x equals a number, 1y equals a number, we'll be done, is what I'm eventually trying to say. So our focus, we actually become much more focused on what's going to get us to the answer. Zeros in a matrix are awesome, because the 0 in a matrix tells me that that variable is dead. So if I do this, and let me from the very beginning show you how I do this so that we're not rewriting the matrix. In order for this to really help us and be quicker, you don't want to rewrite this matrix more times than you need to, because it's kind of big, and you can imagine if it was 8 by 8. Screw that. And a quick word on that. The true technical dimension of this is 3 by 4. This is a 3 by 4 matrix. So the number of rows by the number of columns. You with me? And one way we're gonna do this in the calculator too, so that you can check your work when you've got a problem like this. And that becomes kind of important to know at the beginning. You've got to tell the calculator how big of a matrix you want to create. So here's what I do. We're focused now on rows, And the beauty of the matrix is it lets go of an equation that's no longer as good as the new one. It will only ever have 3 rows in it. But I keep replacing old rows with new ones. Because the old one is no good anymore. It's not as good as the new one is. The new one's got 1 less variable. So if I were to do twice row 1 plus row 2, now the question really becomes, and are you guys with me? Isn't that what I did here? Twice equation 1 plus equation 2. So now we can look at them as rows. Twice row 1 plus row 2. And where do you think my goal is here? Where do I want to end up?
Zeros and ones.
Zeros and ones. I love it. So let's be a lot more specific. My goal is going to be to get here. Now, why would that be my goal? Because this says, what does this first equation say?
X equals
1x, so x equals whatever number that is. Y equals a number, z equals a number. That's my ultimate goal here. There's an intermediate step that I'll come back and talk about because the book talks about it, but it's best just to take this matrix all the way down. Reduce it all the way to here. So if I do this, where do I want to put the answer? What's going to happen if I do twice row 1 plus row 2? I'm going to get a 0. Do I want to put it in row 1 or put it in row 2? Which row do I want to put it in? Which equation do I want to get rid of? What gets me closer to my goal? I want a 0 here, so I'm going to put it in row 2. Okay, all right. So I'm going to put my answer in row 2. Let's see what that looks like. Here's what I do. I do not, please dear God, do not rewrite this thing and do a 2, 2, 2, 8, negative 2. Oh, screw that. Just put up here for a second. Twice 1, twice 1, twice 1, twice 4. Now add them. 2 plus negative 2. 0. 2 plus 3 is 5. 2 minus 1 is 1. 8 minus 1 is 7. Isn't that the exact same equation there? 5, 1, 7. 5, 1, 7. Yes, sir.
If we were trying to solve this, like, why would we do this first step? Why couldn't we just directly go and do this, cancel the first and the second?
Because I'm trying to show you what that means. How does that new method compare to the old method? You're right, I would not do both. That would defeat the purpose. All right? I'm with you on that. But the only reason I did this was so I can show you right now what I just showed you. That's exactly what you would have gotten the by hand method here, the non-matrix method, I guess I should say. The other one would stay the same. Let me just stop right there. Let's do a little self-evaluation. How are we feeling about this so far? It's very much like synthetic in the way that it tries to set it up. It tries to simplify what I'm looking at. It refocuses what I'm looking at. It really changes what I'm trying to make happen. Zeros mean a variable's gone away, but it's just a different way of looking at it. And anybody who does any computer programming a computer to look at it as a matrix is a lot easier than trying to do something with this. You just tell the computer, find a 1, make everything else 0. Find a 1, make everything else 0. If it's not 1, divide, make everything. Computers can handle all weird-ass decimals and fractions and stuff. What would be the next step here?
Get through to 0.
Yeah, so my goal, I always start with the first column. I got a 0 there, I want a 0 there. And again, I didn't hear anybody saying that they were completely lost. So I'm going to show you kind of the next level of shortcut to try to really make matrices even more efficient. I would put underneath here, with the marker that works, kind of the next thing I would do. So I don't have to rewrite it. I already rewrote it. But what would I do next to kill this 3?
Multiply by row 2.
Yeah, so I want to do row, negative 3 times row 1, plus row 3, and put the answer where?
Row 3.
Row 3. So you just stop right there. Two reasons you want to do this for yourself. One is if you're here and you go, wait, I think I made a mistake, and you didn't write this down, you might forgot what the hell you just did. Two, I'm trying to grade these damn things. Please give me some idea of what you're trying to do. So if you make a simple mistake, I can give you some partial credit. If you don't write this down, I have no idea what you're trying to do. I have no idea if you know what's going on. Give me some idea what you're doing, right? So, I mean, if I do it the same way I just did it, I would just put up here, 1 times negative 3 is negative 3, negative 3, negative 3. 4 times negative 3 is negative 12. You guys semi with me? That'd be the exact same thing as multiplying this equation by negative 3. I would get those coefficients. It wouldn't make sense to rewrite the matrix because the next thing I would do is divide it by negative 3 again to get the 1 back. So why actually change it? Just write what it would be. You only need it for a second. That's why, truly, to tell you the truth, I would do both of these at once. You know, there, and then there, and then that's a lot more efficient. Now, if you don't understand what I just said, or the sounds I just made, or whatever, then that's fine. You can keep doing it one step at a time. But there'll be a big motivation to kind of truncate this process if you're redrawing these matrices over and over. So what does that become then?
0, negative 3.
Yeah, see. First thing stays the same. Second row stays the same. Third row becomes 0, negative 4, negative 1, and negative 6. I love it. I just need tons of room for these. You good so far? So I got the first column done. Now I can move to the second column. Somebody help me out. Why wouldn't I multiply this by 4 and add it here? That would kill that 4. It'd be awesome. I get a 0 there.
0, 0.
But I'd also get a 4 there, wouldn't I? So I never want to do that. I pretty much want to use these guys. I always think of them as more like lasers. So I do some laser surgery instead of just taking some hammer. You will be better. So I can focus right on what I need to focus on. But here's where, let me see if I can get this. Here's where you can be a little bit creative, thank God, because if you did it the way a computer would do it, all you would do is divide this by 5. Now, can you see why you don't want to do that to yourself? My God, right? Of course, my old teacher made us do that. He said, you must do it just like a computer would. I'm like, why would we do that? Doesn't make any damn sense. I'm not a computer. So I can be smarter about it. And this one, I did not plan this out ahead of time, but it really kicks ass. There's more than one way to get a 1 somewhere. I can just add these 2 rows, and then that's a better equation. Why? Because it has a 1 coefficient right where I want it to be. Try that again. Yes, sir.
Can we multiply by 4? Both of them, that would make 20.
You would multiply this by 4, you can multiply this by 5, and that would kill them, but you still wouldn't have a 1. Let me make sure you guys are still with me. Because what's my next step in my overall goal? To make this column look like 0, 1, 0. So if I get the 0 first, that's not that big of a deal, but then I'm kind of screwed. Because now I have to work with this 5, 1, 7. And I have to divide by 5. No. So, but you guys see how this is actually a little too good. I wish it would have been this nice, but this is way nice. I just have to add these, and I get a 1.
0,
1s are awesome. They are like my lasers. Right? My laser. So, if I add row 2 to row 3, and I put it where? Where do you think? What makes the most sense?
or row 2.
Yeah, I'm going to get a 1, so I want to put it right where I want my 1 to be. I'm going to put it in row 2. So see how this might be a brand new process for a lot of you guys, but if you've gone through our 110, hopefully most of your teachers have shown you some matrix stuff. How many of you guys have never really seen what I'm doing right now until I started doing it? All right, so most of you guys have seen it, or you just don't want to put your hand up. I understand. So if I do this, the first row stays the same. The second row is now 0, 1, 0, 1. That kicks ass. And then I get, leave this guy alone. And now do you see how beautiful that one can kill that one? And this will not screw with that one. You guys with me? Having zeros around your one is nice. It won't mess with anything else. And then I can use this to kill that -4. That kicks ass. I got a little bonus. This is almost too nice of a problem that I made up out of nowhere. I already got a 0 there. That's kind of nice. So what would be my next step here? What can I do?
Subtracting row.
Cancel the
Be very specific. Multiply this row by 4. Okay, let's do that first. So 4 row 2 plus row 3. And put the answer where?
Row 3.
Row 3, because I want a 0 to show up right there. Now, I'm not going to make you do like a ton of these. I'm trying to remember how much homework they gave me here. But, because once you get the process, you really have no reason to do more. I mean, it just becomes busy work. The process, and you can imagine, if I make this a much bigger matrix, the amount of work involved does not grow as quickly. If I put one more equation and I started doing X and Y and Z and W and I had to do it by hand, oh, screw that. But this, I add one more layer on here. It really doesn't add that much to the amount of work I'm already doing. I just have to make one more 0 somewhere, right? Okay, maybe. So now, if I do this, multiply by 4, that's 0, that's 4, that's 0, that's 4. Add it to row 3. So then I get, this stays, this stays, this stays, this stays. This is the same. And this becomes now 0, 0,
Minus 1.
-1,
Minus 2.
-2. So we already know an answer. Right, I can multiply this row by -1. So I already know that what is what? Z is 2. I love it. I love asking questions like, what is what? Thanks, teacher. It really helps. But no, Z is 2. I know that now. Now, somebody help me out. What is this equation? What do these equations look like right now? What's the first equation look like?
X plus Y plus Z equals 4. Y.
Yeah. What's this one look like?
Y equals 1.
Y equals 1. That kicks ass. And Z equals
2.
2. So I could just plug these in here and solve for X. That's an awesome idea. Or I could just take a second and kill this one.
Do it.
And kill this one. Right? So either way. So the kind of, this, right now this is basically what's called reduced echelon form. How important are the words? Not really, but they actually correlate to what's in your calculator. So this is reduced echelon form, which is where you have zeros here. You don't have to have a 0 there. That was just lucky, remember? If you have zeros here, that means you know what Z is. You can plug it in and figure out what Y is. And you can plug those in and figure out what X is. If you go all the way to this, this is called reduced row echelon form. Again, how important are the words? Not. But that idea of reduced kind of makes sense. You've gone as far as you can with it then. Like reducing a fraction. So if I did go a couple steps further, what can I do? I could do negative row 2 plus row 1. Right? So this would be 1, 0, 1, 3. And then I can do -1 times row 3 plus row 1, and then I'm done. So that would be -3 there and -6 there. No, Jeff, not -3. -1 there and -2. And again, you guys are cool. I'm using that one to kill that one because I know what my goal is. I want to make zeros in these certain places. So that would finally get me to the point where I got 1, 0, 0, 1, 0, 1, 0, 1, 0, 0, 1, 2. Whew, jeez. So what's the answer? X is 1.
1.
Y is 1.
Y is 1.
Z is
Z is 2. 11. Otherwise known as 0.112.
Change sign. +1 and +2.
Oh, I just multiplied it by. They're both negative, so it's the equation negative z equals negative 2. So I can multiply that row by a negative.
By negative.
I can multiply any row I want to by any number except 0. Can't just make them all 0. And I can add or subtract any two rows from or to each other. Yeah, is that cool? You can do everything with these rows that you could do with your equations because these rows are the equations. Yeah.
How come the Z is 2?
Yeah, we do that from right here. No x's plus no y's plus z equals 2. Cool. Alright, maybe.
Is there a bracket on that answer?
No, not really. I just was standing too far away. It's just trying to be a point, not some kind of weird triple interval notation. Alright. So let me give you this handout, and then I'm going to have you guys do one on your own. So I got a little handout that's got a fully worked out problem, just to make it a little easier to refer to. Yes, ma'am. Oh, hell yeah. Oh, hell no. So obviously I'm going to give you one that's going to be relatively straightforward, because you certainly can get a few that get a little freaky. So on the test I can't give you one that's crazy, and I would highly suggest you do that problem last. Because it's not, even if I give you a matrix that's basically easy, all you got to do is forget a negative sign, and the whole damn thing goes to shit, right? That's the hard part of these problems is it doesn't take much to throw the whole thing off. And you're getting answers like 117 over 98, and you're like, Jeff sucks, man. What the hell? Like, it's not me. Let me give you this, and I'll put up here a problem for you to try.
I get it now.
I thought was
It's tomorrow. There's no practice that can help you tomorrow night, as long as you're home.
but I have an appointment. But today, if I have test, I'm not going to the class. I'll go buy your place and I'll go to Starbucks and read the book.
The book won't help you.
It has copies in the back. Or on the back of the
Write this stuff down right here. Write it down.
I think I have it.
Just let me know if my printer is really acting up. So if you got one that's like off kilter or something, let me know. I can give you a nice one. There's only one side to it, so that's all right.
Just hold it like this.
So you guys attempt this problem. We got what they want here?
So it's better to do it
More than you ever wanted.
See? Better to do it downward than should we do it downward or across?
You start it from down.
I know, but downward or across?
Wait, to write it?
Down.
See, it's easier to see it. Because you have your matrix, and then you have your rules.
Rules! Everything has
And then your
rules.
matrix, and your rules, and your
You write your rules on top.
well, just in between, because this rule relates to that. But you're trying to do
It like has all these things you learn as a I have to do it and you can't put it on plan. So I just have to
by negative. Now cancel negative 1, 0.
Okay.
Oh, that was the first.
I could, the rule of, I'm just going to do this too. I'm going to say
R1.
negative 2.
Just the beauty of that, you just read it right off at the end there.
Well, no, that's what it's next step. All these cases.
That's why it's intermediate.
All these times 2 times 3 plus that. 1 cent. So if you multiply that by 3, that's 5. So I did times 3. Oh, okay. So I see 8. Yeah, for that, and then after that, all these times 3 because that's where I got my 20.
Oh no, I'm gonna add these two together. Should I put them in like that? I did leave on just 1 point and 1 3 over 1 plus 4 0. 3 over 1 plus 4 minus 11. Which it went too hard. Yeah, it went too hard. Here, plus 1 2 is 11. We have 8 plus 3. Where? Yeah, here. 2 over 2. That's positive 8. Minus 2 minus 4. We want to go this way first.
You want a 0 here.
We want a 0 here first. Yeah.
But you can't get 11.
11 plus negative 1 is 0. So I'll do that.
But then you need a 0, but you need a 1 at the bottom.
Okay, I'll do that. They're all zeros? Why not?
Because you have a 0.
Can't have a 0? They're all zeros.
See?
Now what do I do now that I've got all zeros?
But then you can divide by 2. Yeah, definitely. Yeah.
And look, there's all something back here again. I'm sure we did this right. There's an arrow. Let's add a
You should make the
You get the same thing I got?
The last one should be 0, not 13. Row 2 plus our row 3. Let's just keep going.
I'll just do it. You can.
Because I can go row 1. I got
Get rid of them. You're supposed to work from the top. We're supposed to be forward. We're supposed to get this as a 0. No, now you can do.
Let me catch up to you guys. You know, I always gotta remember, I'm so used to the general way of doing whatever size matrix you have. There are a couple of, if you only have a 3 by 3 like this, you know, officially 3 by 4, but 3 equations, 3 unknowns. There is one little intermediate step that makes it a little bit easier. I think most of you guys should be ending up with like a 9 and an 11. Does that sound, if you've gone the right way, that should sound familiar? If you don't have a 9 and an 11 somewhere, then you either chose a different path or something went a little freaky. There are a couple other things you can do.
Row 1 plus row 3.
So I think the few people that I was looking at, their papers, the first couple of steps are pretty simple, especially because there's a 1 there already. Now obviously, if there is no 1 there already, you can kind of try to create a 1 there. You desperately want to stay away from dividing and getting all these fractions, because even though we're in pre-calculus, we should have no problem with fractions. Why do that to yourself? Right? It just makes it so much harder than it needs to be. So what can we do here? How do you kill this guy? Yeah, -2 row 1 plus row 2 and put the answer in row 2. And I can also do, to kill these, yeah, multiply by 3, so 3 row 1 plus row 3, put the answer in row 3. I'm going to test this a little bit, see if we can handle this. So here's my -2, 8, -2, -14. That's doing this. So what do I get there? I get, this first row stays the same through this whole thing. OP17. -2 and 2 is 0. 8 and 3. -2 and 1. -14 and 1. You guys with me? And then what I would do is, just so my eyes wouldn't wander, cross those out, and now multiply by 3. And then we've got 0. Let's try to keep that one covered. Yeah, 0. Where am I at? Negative 12 plus 1.
9. Not 11.
Where am I at?
Yeah, that's what I did.
Yeah, negative 12 plus 1.
Negative 11.
Negative 11. Oh, that's even better. Okay, no 9. Yeah.
But then it goes,
Which way
It
did I
goes
go?
all
but
to
then it
0.
goes to 0.
Oh, I did something different than this. You're fine. That's all right. My bad. And then you get, what here? 3 minus 2. 1. And then 21 minus 8.
So we're up to
2 row.
13.
so,
Oh, I had to go do this to us, didn't I?
yeah, because we're all at 0 now. We're all confused.
So what happens on the next step? You guys might remember how to
Zero's
interpret
out
this.
the bottom one.
Yeah, beautiful. So no 11 and 9, that's my method. So when you add these two, if I add row 2 to row 3,
We did one right here.
I get 0, 0, 0, 0. They all cancel out, right? Who remembers what that means?
That means
X Z is not there.
Z. Oh.
It's
Yeah, they could all be, this first row is, I can still work on this a little bit. I can still try to kill these. Don't worry, it's not my intention.
what are you doing to us,
0, 0,
John?
1 in the last. You got 4 zeros.
That's right. That's right. Oh, I see that.
It's a 4 row.
All right. So that was my unfortunate occurrence. Now watch this. This is interesting. And I never looked for this because the chances of it happening just out of nowhere are very slim, but of course it happened to me just now. If you go with me for a second, I'm going to try to explain why this happened. I didn't want this to happen, but that's going to happen sometimes in your homework. It was just a little too soon for me. X plus 2x was the opposite of that.
Oh.
Negative 4 plus 3, negative 1 is the opposite of that. Z plus Z is 2Z, the opposite of that. 7 plus 1 is 8, which is the opposite of that. So, but I just made this up randomly. I just happened to be incredibly unlucky because the chances of it happening just out of nowhere. And this is why this kind of system, when you get zeros somewhere, it's called a dependent system. Why is this called a dependent system? Because this one depends on these two. This is the sum of the negatives of these two. So that's why it's not, I didn't really give you a third piece of information. Like the example I said, yeah, I'm twice as old as you are and you're half as old as me. That's not really two pieces of information. So this is not a third piece of information. That's why that happened. So how do I actually handle this?
You have to solve for the other two.
Exactly. So I've got x minus 4y. That's not 17. Plus z equals 7. And I've got 11y minus z equals negative 13.
So we just do a smaller matrix?
So here's the cool thing I can do. Do you see how I could say z is 11y plus 13, right? Mm-hmm. And x plus z is 4y plus 7. Are you guys with me? Just adding that y over.
Yeah.
And I'm trying to stay away from trying to really get this because that's ugly to make it into a 1, but there is kind of a way around that. And I'm going to use that way right now. Then I can plug this in here. Kind of work with that a little bit. I'm trying to get everything in terms of y, because then y can be my t. I don't know if you guys remember. If you have If you can't get a single answer, you get a row of zeros. That means that one of your variables is going to be a parameter, and everything else is built off of that. We talked about that last time. So here I get, move this somewhere. I get x plus 11y plus 13 equals 4y plus 7. So I get x equals negative 7y minus 6. I have z is 11y plus 13. And I have y is y. So I can say y is t, x is negative 17 minus 6, and z is 11t plus 13, and that would be my answer. Now that was more than I wanted to do this early on. I normally have to kind of force that to happen when I want to get there. I did not want to get there at the moment, because we're all still getting used to matrices. I really didn't want to do that to us too early.
Oh, you did? How did you get?
I know I did.
Y is t? How did you do that?
Because everything depends on y. So I give y a value. So the reason this is a weird system is because I don't have 3 pieces of information. I'm not going to be restrained to one answer. If I have, I really just have 2 planes here. I really just have 2 planes here. So if I have 1, 2 planes, where do they meet? If they do meet, they meet. Now, careful. I have 1, 2 planes. They meet at this line. You with me? Do they meet at a single point?
No.
No, they meet at an infinite number of points. It's exactly what this says. You can make y anything you want to, and then x has to be this, and z has to be that in order for it to stay on that line. That's the idea. So there's an infinite number of answers. And we know that when we get, what does this last equation say?
Says that z doesn't
0 equals 0. What does it mean?
Z doesn't care.
Infinite number of answers. There's my infinite number of answers. They're a very specific set of an infinite number of answers. There they are. So you make y whatever you want to, and you get 1 point that's on that line where they meet together.
Could you have turned that around and made x equal t and then written out whatever you would have gotten?
Well, I need to make the thing t. I could have, but I would have made some ugly, and which is not that big of a deal, but it would have made some ugly coefficients, some fractional coefficients. It's up to you, though. But I wanted to do y is t because x and z are already
In that.
nice in terms of y, with no fractional exponent coefficients, so I didn't want to do that to myself.
Sure.
Yeah. All right, so that was a little sooner than I wanted to, but we eventually have to handle these kind of problems anyway. We're going to see a few of these in the homework. The important thing is, did everybody understand the first step we took at least? To get rid of this 2, to get rid of that 3? Okay, and basically just carry that idea throughout the matrix. So let's do this. Let's try maybe one more together. Then we'll take a break. Then we'll do some new stuff. Maybe this time I'll take one out of the book.
Okay.
They seem to be reverse lucky tonight. Let's look at page 660. It's number 23. Just a quick inspection. It looks like those should be okay.
Yes, we got to do another one.
Did not mess up. The order of my teaching was set by some higher power. Always known as a screw up. So yeah, go for it. Might as well try it out.
Can you times it by a fraction?
Let me ask you this, and I'll just tell you, you can do this, because part of the whole thing behind this is just getting used to what are you allowed to do in this format, and then just getting used to how to kind of work within this format. What do you actually look at? What do you look for? How do you get to where you want to be? There's a 0 here. Do I really want a 0 there in my overall scheme of things?
No.
So what you could have done in the very first, I don't know if anybody did this, you can actually switch those rows. Because the order that they gave me the equations in, did it have to be in that order?
Oh.
Hell no. So if I have a 1 here and there's a 5 there and a -4 there, I can just put that first because I want a 1 to be there.
Oh. Okay.
Right? So you certainly can switch the order because it's arbitrary the order the equations are in. So you can switch rows all day long. So I won't do that because it looks like most of you probably didn't do that. Just working with it the way it is. Which means at some point you're going to have to lose that poor little 0 maybe. So what you can do is,
-1.
yeah,
Negative
row 1 minus row 2 maybe. That's basically what you guys did.
Change the sign.
Negative row
And then
1
-2 row 1
plus row 2.
plus row 3.
Yeah.
So see if that matches up with what you got.
So far.
In the first equation we did -1 row 1
Yes,
plus row
same
2.
thing.
And so you're going to get the negatives of what I'm about to get.
Yeah.
Right? So if you do this, you get, the first row stays the same. You get 1 minus 1 is 0, 2 minus 0 is 2, -1 minus 1 is -2, -2 minus 0 is -2. So did you get -2, 2, 2?
Yeah.
Yes.
All right, sweet. All right. So we get the same thing.
We can always change.
And then -2 row 1. -2, Jeff. Where are you going? So you get -2 and 2 is 0. -4 minus 1 is -5. 2 minus 1 is 1. 4 minus 3 is 1.
That's when we're all kind of stuck. Yeah. We're like, how did
Is
you
that-
roll 5?
Matching up?
No,
Yes. How do you get rid of the
I
5?
got 1 0 0.
Where?
1 0 1.
Row 2 plus 1.
First row.
Oh, you moved that there?
This one's row
Kick
2
ass, so
minus
did I.
1.
We're just hanging out. Let's see if we get the same answer this way. What's really nice, I don't really have a 2 and a -5 to work with there, do I?
Why?
Because you're always wanting to work with the 1. So the best way you can get that 1 is if you don't make any fractions by making this a 1. And I won't. If I divide by 2, I don't get any fractions. I'm not making this harder than it needs to be. I get a beautiful 1 right there, which can then kill both of these things. Some of you guys might realize, I can just make this negative what it is right now and kill him. That's beautiful. Whatever way you want to look at it makes it work. So I'm going to go ahead and just take half of row 2. And then I can just build it back up to be whatever I want it to be. So I want it to be, to kill these do -2 row 2. I want to multiply this by -2 and add it here. That's going to make that 2 disappear. And then, of course, I'm going to multiply this by 5 and add it there. So then we get, let's see, here's my -2 row 2, so it's -2, 2, 2. 1, 0, 1, 0. Yeah, that sounds familiar. We basically recaptured that. Instead of moving up here at first place, it kind of came back on its own. And then I get, for 5, I get 0, 0, -4, -4. And the first row is still the same. Oh, I'm sorry, which one? The middle row is still the same. Here's working on the board with these things. Okay. So again, if you're not comfortable doing kind of this two thing at once deal, you don't have to. You can only ever change one row at a time until you get more comfortable with it. You pretty much always want at least one row to stay the same as you're doing things. Because that's the row that's kind of changing the other two, so how can it change itself? There's always going to be at least one row stay the same. And now I've just got a couple things that I'm done.
Minus 4z equals minus 4.
Yeah, if I want to go all the way out with this dude, I can make this into 1, 1. You guys are cool. I've developed a way so I don't have to redraw the whole matrix a lot of times. That's what makes this really, really brain numbing. So I just do that. I can make them 1, 1 by dividing by negative 4. Is that cool? So now I can kill that immediately. Just do row 3 plus row 2. Row 2. So I get 0, 1, 0, 0. And then do negative row 3 plus row 1. 1, 0, 0, negative 1. And of course the last row is good the way it is.
What was that last thing you did?
Oops, sorry. I did negative 1, row 3 plus row 1. Just to kill this guy. Second one. So then my answer is what?
Negative 1, 0.
Yeah, negative 1, 0, 1 as a point, or x equal negative 1, y equals 0, z equal 1. You, of course, can always check your work by just plugging it back into the equation and seeing if it works. So before we take a break, let me show you how to do this problem on the graphing calculator. Then we'll take a break.
Like on our test, like right there, we saw that z equals 1. Can we plug it back in just into REF, or do you always want us to have our REF?
Depends on what I say. If I say solve using a matrix,
Solve all the way, or
I would probably say solve all the way. Yes. Okay, so let's see how this works in your graphing calculator.
Okay.
So your answer is 1, 1, 1.
So maybe let's take a break while I figure out what somebody's done to my monitor here. So come back at 15 after, and then we'll look at how to do this on the graphic calculator. I've got some up here if you need to borrow some.
Alright, I better know how to do all this. What is my PV equals NRT? Do you have that thing I gave you, Bruce, with all of the chemical reaction equations on?
That's what we're